Hello everyone, welcome to our pre-calculus class. This is our lesson 7, graphing cosine function and finding an equation for a sinusoidal graph. These are our main topic for this lesson. So these are the agenda: graphing cosine function, finding an equation for a sinusoidal graph, and then some discussion about the sinusoidal graphs, then practice homeworks. So let's start. First of all, just like the sine function, actually we can draw the cosine function also. We can think about what are the values of cosine different angle. Say cosine 0 degree equals to what, and then cos of let's say 30 degree equals to what, 45 degree equals to what, 60 degree equals to what, 90 degree equals to what. This way we can actually find out a lot of values for cosine of different angles. Okay, say let's say 90 degree equals to what, 90 degree equals to what, then 270 degree equals to what, 180 degree equals to what, etc. We can find it out from the unit circle also, which is much easier. This is 1 comma 0, this is 0 comma 1, this is minus 1 comma 0, and this is our 0 comma minus 1. So this helps actually in a way. This unit circle helps actually to get the answer very quickly. We can see that our for cosine function, for first value x value is the cos, so cos 0 degree value is 1, cos 90 degree value is 0, 90 degree value is 0, 90 degree value is 0. Then cosine of 180 degree, this is 180 degree, 180 degree value is minus 1, and 270 degree value is 0, this is 0. Again 360 degree value will be 1, because if we come back then we will hit the same point. So 360 equals to again 1. All of them are cos, and we can actually, if we want, we can actually find out more smaller and smaller values as well, which is also fine. If we take more and more smaller values, this is actually better in some sense, because then we will actually see the more closer variation or changes in terms of the curve, how the curve moves. We will see the more closer look if we take the smaller and smaller value. But for our purpose, for current purpose, I think this should work fine. Our maximum value is plus 1, minimum value is minus 1, and this way we will try to plot it just roughly. Let's say this is our 2 pi, or we could write here actually 360 degree also. 360 degree means both is fine. Okay, let's write 360 degree, 360, and this is 180. Then this is 90, and this is 270. Okay, now see, this is 0 degree. 0 degree means 1, so 1 is here. 90 degree is 90 degree means 0, so 0 value is here. Then 180 degree is minus 1, so 180 degree is minus 1 is somewhat here. Then 270 degree is 0, so 270 degree is 0 here. Then 360 degrees again 1, so 1 is somewhat here. And if we draw the graph just roughly, then the graph will look like something like this. Something like this. And of course this is the end for our values, but if we continue, then the graph should go, graph should proceed that way. Okay, graph will continue this way. This is 360 means 2 pi. If you want to write in radian, 180 means pi, and 90 means pi by 2. This means 3 pi by 2. So now I think you can see a general shape of the graph. Okay, and if you want to compare it with the sine graph actually starts from our center. Sine graph is like this. Yeah. And see the variation. So sine graph actually starts from the center, from the origin, and cos graph actually starts from positive 1. Okay, positive 1. Although both of the graph actually goes to the plus 1 and minus 1. So there, this is how they move. Okay, this is their maximum and minimum value. So positive 1 and negative 1. So we have to keep in mind very carefully that our cos graph will always start from plus 1. Yeah. Then it will start coming down, and sine graph will start from 0 and it will start going up. Okay, I mean this way, if you consider it this way, then it helps in the future calculations and reflections, decision making, etc., etc. So this is the final graph. You see, final graph is this between 0 and 2 pi. Another important thing to notice is in the sine graph, you see we draw from here to here. So one graph finish, this is one full wave, but cos graph is peak to peak. Okay, peak to peak. So this is the top upper point, peak, another peak is, so peak to peak is one full wave. So we can actually think about it this way. Of course, we can consider from here, then we have to again come back up until here. But since we started from here, so best idea is to look at this. Okay, we started from here, so another peak is here. This is one full wave. Of course, we can continue because they are periodic, so we can continue it in the both of the direction, in the both positive and negative direction. We can continue since they are periodic, so they will continue forever this way. So this is the graph of cosine function, and sine and cosine function, they are actually interrelated in many ways, and for understanding them, this is good idea to keep both of them side by side. Anyway, let's look at the properties of the cosine function, which is actually similar to our sine function, as we said. Similar couple of properties we will see here. Let's keep it here. You see the domain. What is the domain of the cosine function? So domain means the x value. You see the graph is moving in the negative x direction forever, in the positive x direction forever, which means the domain is all real numbers. Set of all real numbers are domain, and the ranges are plus 1 to minus 1. So this is the positive one, this is the maximum value, and the minimum value is minus 1. The graph will confine itself within this band. It will not go beyond it. Cosine function is an even function as symmetry of the graph is with respect to the y-axis. So you see, if you think about a mirror, about a mirror like this here, and if you fold it, you will see that the graph will actually fall on each other. And just a second, yeah. So if you want to see, like, you see this is actually the even function, and this is actually like cosine function. So if we fold it, then you will see that they actually fall one another. See, you can see just only one graph here. If you fold them about the y-axis, camera is here. So if you fold them about the y-axis, this is x-axis. Okay, this is x-axis reflection. Okay, this is for the x-axis, just to show. This side is better. Yeah, this side is better. X-axis. So this graph will have x symmetry, just if you want to understand, because you see, then if you fold it about the x-axis, the graph actually fall on one another. And for y-axis, this is the graph. This side is better. No, this side is better. Here, this side is better. So you see y-axis, this is actually a parabola, and if you fold it, you will see that they will fall on one another. See, just only one side you can see, just only one, just only this, the red color you can see. That means the both of the side actually fall on one another when we fold it about the y-axis. When we fold, then each of the graph will fall. This means this is even function and symmetry with respect to y-axis. And this graph is also similar. If you fold this both sides, you will see that they will fall You see this point will fall on this point will fall on this point, etc. So this way we understand that this is y-axis symmetry, and if any graph is y-axis symmetry, this must be even function. Of course the graph has to be continuous here to be that. Then we have the period is 2 pi, so period is 2 pi here because it starts, you can see, from here, then we go here, then actually the next thing is the repetition of like the from here as it started, so the repetition starts, and this side also we can continue from the repetition, just like copy, one copy if you have, just you can paste, copy paste, just only if you have one copy, then it is a periodic. So x-intercepts, where we have x-intercept, we have the x-intercept here, x-intercept here, x-intercept here, and if we go back, x-intercept here, and we can continue. The x-intercepts are here and there, and the absolute maximum is here. As you can see, this is the absolute maximum, this is the absolute maximum, and then we will keep continue getting the absolute maximum. This is the minimum, absolute minimum, absolute minimum. So we can see these properties from the value, and where you see occur at, that's why only we write the x value, because we are asking about where. Okay, that's why pi, 2 pi, etc., we write here. So, and also you do not have to memorize it actually. If you just quickly draw the graph, you will automatically start making sense, like where are this thing happens. Why these are necessary, because of this kind of thing actually helps us to later understand the other questions, okay, this is the cosine function, so where it will have the maximum value, this kind of thing, understanding this kind of thing, and the value will be repeating at some particular and constant interval. So this kind of for generating this in the process of generating all this conclusion, this actually helps us. Okay. So this one is how do we find the graph of a sinusoidal graph? This graph is this a sine graph or is this a cos graph? Is it a negative or positive graph? First of all, we have to ask ourselves this question. So by looking at the graph, we have to think, okay, this graph, is it a sine function or cos function, first of all? And you can see basically the shape is, you can see the solution, right? We have to take this one. So basically you can see the shape here, it starts from this point, and which is actually, as you have seen, just like starting from here, the cosine function, you can see the cosine, because sine function starts from the center, cosine function starts from there. So you see this graph looks like a cosine function. First of all, this is our decision number one, and you can see that this is just the regular cosine function. This is not the reflection. Suppose our regular cosine function is like this. Then the reflection, which is negative, we are saying negative, then the negative cosine function will start from here, because that will be the reflection of about the y-axis, about the x-axis. So this will be the negative cosine function. Positive cosine function will start from here, and the reflection is the negative cosine function. But we can see that this is just normal cosine function because it started from there. So our first decision is this is a cos function. This is the question. Is it a sine function or cosine function? Then is it a positive or negative? So we can see that this function is positive because this is just a regular cosine function. So this is positive. Then, so we know that this will be this formula, not the sine. This will be cos. Now we have to think about what is the value of A. A value is what here? So we know that A is the amplitude, and you can see the amplitude is 3 here. So that means A value must be 3. Then what is the value of omega? Yeah. So we know that there is a formula, nice little formula, which is called T equals to 2 pi divided by omega. 2 pi divided by omega. So T is the time period or period. So what is the period here? So here you see this is a peak, and next peak is here. We know that for cosine function, period is peak to peak. So you see our period is 1 on that one wave is at 1. So that means our period is t equals to 1. T equals to 1 in this math. So we have 2 pi then omega. So omega equals to what? So omega equals to what? If you do the calculation, omega equals to 2 pi. So ultimately now actually we have the answer. Technically we actually have the answer now. So that means this a value will be 3 and this omega value will be 2 pi. So that should be our answer. That should be our answer. Let's see if we got it right. So you see, yeah, it looks like everything is fine. So 3 cos then 2 pi x. 3 cos, let me bring this 3, this is that 3, then cos, because the graph is cosine graph, then 2 pi is the value of omega. We have found it from the calculation. So this is how we can actually get the equation if the graph is given. If the graph is given, then we can actually, this is how we can get the equation. Let's do another practice from here. So this graph. So first question, again we have to ask ourselves, first question is it a sine graph or cos graph? And you will notice that first of all this graph actually goes through the center, so it must be a sine graph. It must be a sine graph. And also you see our regular sine graph should go like this, but it is going downward. That means it is actually there must be some reflection here. Okay, so first decision is it is a sine graph. Second decision is this must be negative. You understand? This must be negative because sine graph should go like this. Sine graph, normally sine graph should go like this, but it started growing in the opposite direction. That means it must be negative. So we know that this will be sine, and then we know that this will be negative. Okay. Now what is the period? What is the period? So you see one full graph is if it start from here, then it goes there, then here. Okay, one full graph is here. So what is the period formula? We know same formula we will use. Before finding the period, we can find out the amplitude also. You can see amplitude is 2. So amplitude is no problem. Amplitude is 2 because that's the easiest to find out. Now period. Again, period equals to 2 pi divided by omega. That is the formula. And omega, and period equals to 4 as you can see here. So that means this value is 4. So now omega equals to what? Omega equals to 2 pi divided by this 4. Now we can do this cancellation, little cancellation here. So it will become pi by 2. Pi by 2. That means this is the value of our omega. So we can write here. So our final answer will be, first of all, this is sine function. So this one, this value is 2. Omega equals to pi by 2. Pi by 2. And this is a negative function. So there must be some negative sign before the function. Okay. Let's look at the solution. And you can see the solution here. See, minus 2 sine pi by 2x. Minus 2 sine pi by 2x. So just same as we have written here, minus 2, first of all minus 2, then sine pi by 2x, sine pi by 2x. Let me erase it so that you can see it clearly. Minus 2 because 2 is the amplitude, graph is reflection, that's why minus, and this is the value of omega. Value of omega here. So this is how we understand. We can find out the value of a given graph. Some graph is given. This is how we can find the answer. Now, one important relationship of sinusoidal graph. This is slightly, you will need to think about it actually, what's going on here. You see, this is the cosine graph. This red color is the cosine graph, and this blue color is the sine graph. So this is the cosine graph, cos graph. And then the blue color, do I have this color? Is this that color or is this that color? Let's suppose this one. And this one is sine graph. Yeah, they're similar. Look at one interesting thing about them. See, if you move this point here, or you can just send it back, or best idea is to, so see, if you move this back, move this forward, just from here to here, what happens? Basically, this graph will fall on this sine graph. Yeah, this graph will fall on this graph. So we can see that actually this sine graph and cosine graph we can uh, uh, just if we move the graph, since the graph is similar, the graph has the same shape, actually they fall on one another. Okay, let me mute it. So they will fall on one another. Do you understand? Which is why we get the sine graph. This is the relationship. We get the sine graph if this cosine graph goes x minus pi by 2. If we move it 90 degree, if we move it 90 degree, then we get actually the same graph. This is what it is saying. We can actually prove it in many ways. This is not the only way to prove this relationship from here, but this relationship is good for visualizing the concept. Visualizing the concept. So, yeah, and you can actually think about it in another way also. Suppose if you have some function like in the y equals to, let's say y equals to x square plus 2, what happens? Our graph goes 2 unit up in the positive direction. Then y equals to, let's say we have x plus 2 or minus 2. Let's say x minus 2, since our question is minus, x minus 2. So this is horizontal shift. So the number, if the number is within the, and we will have this kind of thing also, y equals to x plus 2 plus 2 whole square means now this graph will, this is positive, so the graph will go to the negative way, and this is negative, so the graph will move to the positive direction of it, and this is plus 2, so the graph will go up, and if it is x square minus 2, then the graph will go down. We know that this is actually same thing. This is negative thing, somewhat like this, okay, somewhat like this. So this way we can see that actually we can get from cos graph we can actually get the sine graph if we move it a bit, and then similarly from sine graph also we can get the cos graph. That's why they are called the sinusoidal graph, because both of the graph is they looks like similar, they looks like similar. This is like kind of, in the cinema there is for the heroine, sometimes if there is some big fighting scene or some other necessary scene, then we get their double. This is kind of double of each other, but just they are like someone is 1 hour ahead of another one, or 1 hour behind of one another, kind of that. So yeah, this is the reason why they are called sinusoidal graph, because we can get from sine graph we can get cos graph, from cos graph we can get sine graph if we just move them a bit. Do you understand? And this is, you are seeing it just with respect to this point. Actually this is possible for any other point. Suppose if the graph is here, then also we can actually bring it down to our point or wherever we need, because by using the transformation, because transformation helps us to move the graph wherever we want. Some numbers, some extra numbers will start coming in different direction, because like this vertical shift, horizontal shift, then left and right. So this kind of, or some other things if we multiply it by numbers. Anyway, the conclusion of this is important actually, sinusoidal graph, because of real life situation. We use this concept in real life situation when we model practical life thing in the in some mathematical way. You will see that in some maths that we will discuss in our next class, some application math, there we will be talking about this a bit. That's why we are discussing this topic. Now this is a repetition of another a slide from our last class. This slide I'm repeating because this is actually important one, just to review, so that you just have a look on this once again. Sin x plus k, if there is some number outside, then this is like vertical shift. If it is positive 2, the graph goes 2 unit up. If it is negative, the graph goes 2 unit down. If this h or k, this number is within the bracket, that means it is horizontal shift. If it is positive, it goes back. If it is negative, it goes front. Back means if it is negative, it goes to the right. If it is positive, it goes to the left for the horizontal shift. Let me write it, or else this may confuse. So if this value is suppose plus 2, that means it will go 2 unit up. If it is minus 2, for minus 2, that means it will go 2 unit down. Now here, if this value is plus 2, it will go 2 unit to the back, left. If it is minus 2, it will go to the 2 unit to the right side. This is amplitude, that means it tells us what is the height of the wave. It tells us that this is the omega. Frequency means within some particular space how many waves we have. Is it like this, or is it like this? Okay, so yeah, how the waves are arranged in some. So suppose here we have this is little bit compressed, so frequency will tell us that. Okay, then this is also repetition. We actually solved this kind of math today in the class, and when the period, amplitude, etc. given, then actually we can find out the equation. But it is good to review this page once again, because this concept again we will be using tomorrow in the class for finding the model, for finding the equation from the given graphs. Okay, that's all for today. These are the homework, these are the work, and try to solve these maths. We will be discussing this kind of maths more during the class time. Thank you all, thank you very much, have a good day, bye bye.